Waste products, 4 to 8 pounds per day from each of us. Each year, Americans throw away 26 billion bottles and jars, 48 billion cans, many of non-rustable aluminum, and over 50 million tons of paper. Old appliances, furniture, chemicals, and construction debris are discarded. Agricultural wastes represent a large part of the problem, which is generally overlooked. Automobiles are mass-produced, mass-marketed, and mass-junked. Each year, 6 million cars are disposed of. Yearly, over 72 million tires are worn out and join our mountains of waste. By increasing the use of synthetic fibers and other plastic products, we have further increased disposal burdens. Plastics don't rust, they don't rot. Buried, they remain in their original state almost indefinitely. Burned, they pollute our air. Non-returnable bottles, a great breakthrough in economical and convenient packaging, are a nuisance that will neither rot nor burn. Paper has always been one of our most useful products, but an increasingly higher proportion of paper and paper products make landfills unsightly and litter the surrounding landscape. There is now enough garbage produced in the United States to fill the Panama Canal 4 times each year. How do we dispose of all of it? Increasingly, this seems to be a popular way. A drive along our nation's highways or through the streets of our cities shows our attitudes toward waste disposal. Even though $7 to $12 billion is presently spent on getting rid of wastes each year, less than half of our nation's cities and towns have adequate disposal systems. Over 45% of the disposal sites are operated as open dumps. These dumps contribute appreciably to our air and water pollution problems and degrade the environment. The raw garbage and incompletely burned organic wastes attract flies and rats. For these reasons, open dumping and burning is banned in all states, but it is not being enforced. An improved method of disposal with no burning is called sanitary landfill. It is really a dump in layers. As each load of garbage comes in, it is spread out and compacted. Daily, all the newly deposited wastes are covered with 6 inches of soil, and then another layer of garbage is added. Well-managed landfill sites such as this are both sanitary and beneficial to an area. Most landfills, however, are sanitary in name only. In some coastal areas, wastes are used to fill marshes and extend shorelines under the guise of turning worthless land into valuable property. Biologists are concerned about how the filling of wetlands will affect the ecology. Improperly placed landfills can leach into groundwater supplies and streams, adding pollutants to our water resources. But when carefully located and maintained, landfills can be an efficient and beneficial method of solid waste disposal. Apartment houses, parks, golf courses, highways, and airports are only a few of the things that have been built on filled-in land. In an outstanding forest recreational project in Illinois, soil from the excavation of 3 new lakes is being used to cover garbage in construction of a toboggan and skiing hill. Space for landfill operations such as this will only be available in many urban areas if imaginative, comprehensive solid waste planning is undertaken. To extend the life of sanitary landfills, refuse can be burned in incinerators to reduce its volume and weight. All incinerators operate on the same general principle. Trucks haul in the garbage and dump it into a pit. A crane then lifts the refuse and carries it to the top of a furnace, where combustion, once started, is self-supporting. In ideal circumstances, about 10 to 20% of the original volume of refuse remains as ash or other non-combustible materials. But some incinerators achieve only a 50% reduction. A few incinerators provide useful byproducts, such as electricity and steam for heating and power. But all incinerators have several drawbacks. Besides being expensive to build, operate, and maintain, there are problems involving combustion, corrosion, and pollution. Another way of extending the life of sanitary landfills that is being developed is by compacting refuse in a press. This refrigerator, chair, and several hundred pounds of garbage will be compressed under several thousand pounds of pressure per square inch. The finished bale can be placed in a landfill, or possibly other uses will be developed. Some of our solid wastes can be ground and washed into sanitary sewers. But home units only get rid of part of the waste. Cans, bottles, and plastics must still be collected and disposed of. They also shift the disposal problem from the home to the sewage treatment plant. An effort to convert solid wastes into a useful product is called composting. The product produced is an organic soil conditioner. After removal of ferrous material, the other wastes are shredded, mixed with water, and reduced by grinding to a wet pulp. A dewatering press then reduces the moisture content of the material before it enters a digester. Inside this unit, controlled bacterial action digests the organic wastes in 3 to 5 days. Because there are so many non-compostable items found in solid wastes, composting is not looked upon as a solution to disposal problems. There is also little demand for this kind of soil conditioner because chemical fertilizers and processed sludge from sewage treatment plants are inexpensive and faster acting. We can see that on a national scale, the disposal of wastes is not a problem to be easily solved. Our exploding population will add to the problem. To find a solution, major technological breakthroughs and bold planning are needed. Let's look at a few that are being researched and tested. High-temperature incineration is one. In a furnace burning in excess of 3,000 degrees, all trash, including metals, glass, and plastics, is either vaporized or reduced to a molten slag, which is less than 2% of the volume of the original wastes. A water bath breaks up the slag into small lava-like fragments, which may have many useful applications. Another approach is to develop more readily disposable materials. At Clemson University, scientists are developing a water-soluble glass, which can be used in bottles or other glass containers. This is a test specimen. Before this silicate material can be used for containers, it must be given a thin impervious coating, which protects it from water vapor and corrosion from its packaged contents. Containers made from this glass can be refilled, or the coating can be fractured and the water-soluble glass dissolved. Here, underwater, and with the aid of a time-lapse camera, we get a hint of how this glass dissolves. It could help alleviate a great part of our solid wastes problem, but it could add to our water pollution. There is a growing awareness of the need and the potential benefit of reclaiming and recycling solid wastes. Solid wastes can be looked upon as resources out of place. Therefore, the United States Bureau of Mines is experimenting with incinerator wastes that contain greater concentrations of metals than many ores. In this pilot plant, reclamation of materials is accomplished by washing, screening, shredding, and magnetic separation of the various residues. To date, the experiments have reclaimed an iron product which can be reused. A reclamation plant of larger scale could be attached to a single incinerator, or large volumes of wastes could be gathered from several metropolitan areas for automated processing. The answer to car junkyards might be provided if we had enough huge shredding plants such as this. Some shredders are able to rip automobile bodies and frames into pieces of reusable metal at a rate of 120 cars an hour. It is estimated that $7 million in silver and gold could be recovered from solid wastes each year. These valuable metals are found in photographic refuse, solder, plated, and other materials. This slag from photographic wastes, when cooled, shows evidence of silver. After further refining, pure silver is recovered. In the future, our industries may find it beneficial to reclaim many of the materials currently considered wastes. Each person in the United States produces twice as much solid waste as an individual did 20 years ago. The Public Health Service expects this amount to double again in the next 20 years. Health agencies in other countries expect similar increases. As the world's population continues to grow, we have a choice to make: to continue to ignore the problem and permit our land and water to be degraded, or to develop new approaches which recognize that we cannot throw anything away, because there is no away. Wastes are potential resources, and new methods for processing and recycling them must be developed. As a nation, we set a goal to put a man on the moon, and attained it. But can we attain a national goal to clean up our environment? How much longer can we wait?